In this video, we're going to look at topic 89, example 2, understand rational exponents. So part A, what is the meaning of the exponent in the expression 16 raised to the 1/4 power? So, some definitions or terms. To interpret a rational exponent, look at what happens if you extend the properties of integer exponents to rational exponents. So we're going to assume the power of a power property, which you should be familiar with, but if you're not, it'll be pretty easy here, so don't worry too much. It does not apples, that should say applies to exponents in the form 1 over n. So what we're doing is we're starting with this original 16 to the 1/4 power. Now 16 is the same as 2 to the 4th. So what they're doing here is they're rewriting 16 as 2 to the 4th. The powers of powers property tells me that when I have a power here raised to another power, I can multiply those. So 4 times 1/4 would give us a 1. So this is just 2 to the 1st. We know from previous work that 2 is equivalent to 4th root of 16. All right, so what does all this mean? Really what you can do here is you can take the base in the original, the 16 raised to the 1/4, and that 16, it becomes your radicand. Your denominator in your exponent is going to be your index, and then that 1, your numerator, is going to be here, right? We don't see it because we don't really need to show something being raised to the first power. So how do we do this? If you have something, I'll write this out a little larger, 16 to the 1/4 power, what you can do is you can rewrite that as the 4th root of 16 to the 1st. There's one other way we can write this, and I'll show you in part B, but for now, just know that the denominator, let's stick to our colors, the denominator becomes the index, and this base here, let's fix that. Too much highlighting there. Our 16 becomes our radicand, with the numerator as the exponent on the inside. Okay. The actual expression for that, or the formula, would be this right here. Okay. So in part B, what is the meaning of the exponent in the expression 27 to the 2/3 power? So I'm going to write this in 3 different ways. The first way that they give me, and then we're going to write this in equivalent method using the same kind of process that we just did. So the 27 becomes my radicand. The 3, I'm going to try to use the same colors here. So the 27 is the radicand here. The 3, the denominator, which we're going to put in blue. We're not going to erase it. That 3 becomes my index. So I'd have an index of 3 here. And then that 2 is going to be inside, and we're going to raise the 27 to the 2nd power. Okay, so that 2 will be here. So that's kind of using the process, or we'll say the rule that we used in part A. So your denominator becomes your index, your numerator goes on the inside there where that 2 is, and then the 27, the base in the original, becomes the radicand. You also can rewrite this as the cube root of 27, and then take that entire expression and raise it to the 2nd power. So what you want to be familiar with, or be aware of, is that you can take, the index is going to be the same, right? You can't move the index around. The denominator is the index. However, you can take your numerator and you can choose to write it inside here, or you can take it and write it outside. So effectively what we're saying is that you can take raise it to the power and then take the root, or you can take the root and then raise it to the power. To show that this works, I'm going to show the kind of the math behind it, just to show that all of these are equivalent. Just looking at them, we don't really know that. All right, so I'm going to go with 27 on my calculator, and I'm going to raise that to the 2/3 power. So I'm just going to type 2 divided by 3, and the calculator will do the work for me, and I get 9. Okay. So now if I do the second one, the cube root of 27 squared, what I'm going to do is I'm going to square 27 first, and that gives me 729. So I'd have the cube root of 729. You go to math, select option 4, and type in 729. That comes out to be 9. So notice that these two are equivalent. All right, they're supposed to be. So that tells me that this is the same as this. All right, I can use either one of them. And if I do the third way, you can do the cube root of 27 to start, which comes out to be 3, and then 3 squared, which we'll do on the calculator, but we should know 3 squared is 9. Okay, so it all works out to be the same. So for a problem like this, and what you're going to do in try examples 7 through 12, you're not going to, I'm not concerned with this 9. Don't worry about coming up with a 9 here. You're going to look to rewrite your fractional exponents as radicals with their roots, or write the radicals, like in number 9 through 12, as problems with fractional exponents. So just be able to convert back and forth between the two. You're not actually going to type these ones in the calculator. These specific problems, you're not going to type in the calculator and come up with a number like 9. Okay? You're just going to look to convert from fractional exponents or rational to radical expressions. Sorry. So main thing, again, keep the denominator as the index. The base in your original becomes a radicand. You'll find that, kind of droning on a little bit here, but you'll find that sometimes this is going to be easier, and you're going to find that this at times will be easier. Be able to use both methods. You'll switch back and forth, but either one of them will work for this process.